Hello everyone, this is Sriddhi Sutere and today we are discussing this problem that is insert into a binary search tree. This is a very simple problem. The problem says that you are given the root node of the binary search tree and a value to insert in this binary tree. And at the end you have to return the root node of the binary search tree after performing the insertion operation. Also, it is guaranteed that the new value, I mean the value that you have to insert, does not already exist in the binary tree, and all the other values that exist in the binary tree are unique, right? So also there can be many such ways of inserting this node into binary search tree, and you are free to return any of this. I mean, you are free to insert at any spot, and you have to return the answer for that. So let's look into example and let's discuss the scope of this solution. So in this situation, you have to insert 5 at this binary search tree. Now, for those of you who don't know the property, or let me just recall you the properties of BST. BST is a tree wherein the node value, I mean the values on the left side of this node is always less than the roots value, and on the right side of this node all these values are either greater than or equals to this node value. So this is basic stuff about binary search tree. Also, there is one more thing that we need to keep in our mind while doing this problem, that all the insertions that you are performing, all insertions are made at leaf node. I mean, also you can leaf node. You can add any of these nodes in between as well, but adding a node at leaf nodes, I mean at leaf position, will also be a acceptable solution for this. So this thing we need to keep in our mind. So let's move with this question. First of all, we will consider the node and we will start comparing it with the roots value. I mean the current root that we have at that time. So if the values, I mean let's call it val. So if val is greater than the roots value, so for that case, we will narrow our search to the right side of this binary search tree, because as I've already told you that values greater than root value will always be lying on the right side of this tree. Else we will look up for our search, or we will narrow our insertion for the left side of this tree. Right. So this is the simple stuff. We just have to, I mean, just like other operations with binary trees, we have to deal other cases. And at suppose that we reach at this last index. So if we reach at the last node, we will simply add our value, or we will simply, I mean, for this situation, we have to add 5 at this spot, right? We will first compare it with 4. It is greater than 4. So we will move with this index. Now, with this part, 5 is less than 7, right? So we will look on its left side, and now we will compare that if any value less than this exists or not. So it does not exist, so we will add a 5 in here. So this will be our final insertion. I mean, this is one of our the ways to insert 5 node at this. So we will return this answer as a final answer. So this is the simple thing. Also, we can do this question with two ways. The first could be iterative way, and the second could be recursive way. So let's first of all discuss the iterative way for that, and let's see what I have coded for that. So the first base case would be ki if the root is null, if we don't have a binary search tree beforehand, so we will create a new node and we will return that value, right? Then for the next case, we have created a copy of this root node into a current variable, because we have to traverse these nodes, right? So we are traversing this with the help of current. We have not took root because at the end we have to return root, right? So if we will use root for the traversal purpose, we will lose our initial values of the root. So for that we have took root, sorry, current. Now with this loop, we are running this loop continuously. I mean, we are trying to traverse this continuously until we made a insertion, right? Because it is guaranteed that we will have to make an insertion. So we are doing this, and at any step we make an insertion, we will break out from here, right? So this is again simple stuff that I've told you, that there will be two cases, that if it is if the insertion will lie on the right side, yeah, or if the insertion will lie on the left side. So we have handled the cases for that. And on the right side, if suppose we are getting the values, right, on the right side, like if we are getting the values, we will be traversing them, else we will add the value and we will break out from here. Similar will happen on the left side as well, right? So I hope I am making sense now. So this will be the solution at the end. Yeah, at the end we will return the root. So this was the solution for iterative approach. Now let's look on the recursive solution. Recursive solution is damn simple. I mean, it's the plain recursion that we used to do in other questions. Simply, the first case we will handle is ki if root is null, we will create a new node and we will return that. And simply we will again check for this left side and right side wali condition. So if the condition satisfy for the left side, we will make a recursive call on the left side, and we will have faith that recursion will do our work. And similarly, if the condition satisfy for the right side, we will make a recursive call on the right side, and we will have faith that recursion will do our stuff. And at the end, we will simply return the root. So these all are the solutions. Let's just simply submit this and let's see if these cases passes or not. So you can clearly see that our code passes. So this was all the explanation. If you like my explanation, you can like the video, and additionally you can subscribe to the channel as well. So that's all for this video. Thank you everyone.